Alright, Chapter 14, Getting More from Your Mates. Mates providing for a glue for the Solidworks assembled together would probably handle the mate being able to do assemble the railroad, predictability to change parts exactly the same way that a sketch relation is driven to change and part feature of the result. Mates and sketch relations often have the same function, even the same weakness. And this chapter goes one step further, which mates is not simply putting parts together with the coincident with the concentric mates, but also the remaining parts of real life situations. So if the tolerance gap symmetry becomes issues, you may also learn about the more advanced maybe the types that may be useful in a special situation. One of the assumptions maybe the chapter of the assemble the mates is not just used for the position parts, but also for the motion. Making motion works takes a little bit more than just establishing a right spatial relation between parts. Usually involves in analyzing the open degree of freedom. In this chapter, you will learn to implement efficient managing strategies, perform degrees on freedom and analysis, advance in mechanical mate types, edit troubleshooting assembly mates, choosing mate options, examine the mate best practices. Applying mates. An average assembly of 100 parts is likely to have almost 300 individual mates created with these parts at the time. Looking perhaps at 30 seconds for each mate, you will spend 2.5 hours just applying mates. In this section, you will learn efficient mating strategies as well as speedy techniques apply to mates and parts assembly. Keep it in mind that Solidworks have the high-risk, low-risk mating schemes. High-risk schemes generally involve mating techniques that are easier but more likely to have problems for later in evolution of your model, such as loss, reference conflicts with other mates. More stable mating schemes are favor reference geometry, such as plane axis, possible sketches over model faces and edges. Mating through Mate Property Manager. Mate Property Manager is the default method of applying mates. You used briefly in Chapter 4, creating simple parts and drawings while creating a simple assembly. The Mate Property Manager interface shown in Figure 14.1. You can create mates pre-selecting entities before applying a mate command by selecting them after you open the Mate Property Manager. There are three types of mates: standard and advanced and mechanical. Alright, so you have 13.14 shows the Mate Property Manager. We're under it. You have the Mate Analysis, Mate Selection, Coincident, Parallel, Tangent, Coincident, Lock, Dimensional and Degree, making mate alignment, advanced mates, profile, center, symmetrical width, path, linear coupler, dimension, angular dimension, mate and alignment, mechanical mates, cam, slop, hinge, gear, rack, pin, screw, universal joint, mate and alignment. So there's three different. Add new folder, pop-up dialog, show previews, position only, make for selection. Understanding the mate workflow. There are several different ways to make that I can get around them, showing all the one time and another in the course of this book. It makes a lot of mates. You must have an efficient rhythm when working with the interface, assuming that you have the mate property manager already active. The most efficient way to use the mate interface is the files. Click the first geometric entry, click the second geometric entry, click OK on the right mouse button icon, accept the default mate selection, or select another pop-up list that appears. Alternatively, the automatic default mate type is not the mate that you want to apply. Select the mate you want to pop up on the list shown in Figure 14 to use the mate property manager to get additional options. Alright, mate selection context bar shows parallel, perpendicular, dimensional, radial, locked, undo, rotate. Click the green check mark on the icon pop-up list. Repeat steps 1 through 4. After the last mate, press X key and the green icon or the red icon, either property manager over the confirmation corner located in the upper right-hand corner of the graphics area. Changing the view of the model to position. Sometimes you will have to rotate the model to achieve the correct view in the order to select the face of the edges. Often these times you will want to pre-position the parts of the model stamp in the correct position automatically. You can rotate individual parts assembly by clicking and dragging them with the right mouse menu button. Dragging the right mouse button overall the part rates of the rotates the part. You can rotate the view by dragging with the middle mouse button. You can move the parts by dragging them with the left mouse button. You can move You can pan the view by pressing Control, dragging the middle mouse button. When you drag a part with the left mouse button while Mate Property Manager is active, SolidWorks does not add the selected entity to the Mate Selection list. 3D Spaceballs can both manipulate the view and rotate and or translate parts within the assembly. To summarize these actions, rotate within individual components with click and drag right mouse button, move the independent component with the assembly, clicking the drag with the left mouse button, rotate assembly view with the dragging the middle mouse button. To pan an assembly view, control drag middle mouse button. Be sure Be aware that a view manipulation tool is available. Clicking the triad lower left-hand corner, rotate the normal axis. Click the triad axis for the direction. Rotate 15 degrees about an axis. Specify the angle of the tool's option. View alt-click the triad axis for the direction. To rotate with 90 degrees about the axis, shift-click triad axis in that direction. Activate the mouse gesture wheel and the right mouse button in blank space. Dragging the right mouse button over the part rotates the part. To fit the view, double-click the middle mouse button. Graphic window, same as using the F hotkey. Tip: if you have a spaceball or other 3D motion controllers, you can perform all these actions easily simultaneously using one-hand view rotations on the other end of the selection. You can also use the spaceball to move the parts. Alright, then it has 3 different documents, one with a blue in the middle, and any other selected command. Select other command that enables you to select the items for the hidden other items of the option to use the select face of the hidden behind the other face without rotating the part. You can apply with the select other command with the right menu button. Right click where you face would be could see it list the entities display. You can select the entity you want from listing and from the graphics window. Move your mouse over the entire entity with this list of his highlights. The entity of the graphics window, pressing tab, controlling the mouse wheel cycle enables you in one by one. Clicking the face of the right mouse menu button, which enables zoom the farther down in the part assembly. Click of the left mouse button, either the graphics window or selection list box selects the items. Figure 1413 shows the selecting other cursor with a dialog box. 1413 selecting other cursor with a dialog box. Now we've clicked this. Another 8 selection mate entity with assembly with the option figure 14.1 box on the right, very properties manager, the option make first selection transparent. Not only does the first part that you select with the process of the mate temporarily transparent visually, they are transparent over the cursor. You can pick the items behind with the transparency. Hiding face term of the mate selection. Sometimes it's useful to select with the mate through the faces without using the select other tool. The alt key with the temporarily hide the top face when you're making the mate selection of the works, or using the insert of the mates, edit mates, the copy with mates when reviewing mated entities. The technique is particularly useful anytime you find yourself tempted to rotate the assembly. You can see the bottom of something for the mate. For example, when you mate with the underside of the bolt head to a plate, you might rotate the assembly to see the underside of the bolt head. Instead of doing that, you just hold the cursor over the face so you can't see, but when want to select, press Alt and face obscuring one over the way. When you want to select the hidden, allowing you to select one of them behind it. Again, the select other somewhat less summer. Some of the you can kind of hide multiple faces, which have shown again after the you make a second mate selection. Shift Alt over all single face select. Control Shift Alt to show all hidden faces. Functionality to work with the part of the display shade mode. The hidden face becomes visible again after the selection function shown in action in figure 14.4. Alright, 14 shows the alt key hide face mate section. Temporarily hiding faces when selecting mates. Alt key temporarily hides faces when you're selecting obscured faces from the mates. However, the keyboard shortcut only with the following mates command. Insert mates, edit mates, copy with the mates, and mated entities. The components must be displayed with the shaded with the edge modes. After you select the mate with the hidden face becomes visible when it temporarily hides the face. Control mate, click mate, assembly toolbar with the click insert with the mate. With the focus, with the graphic areas over a face with the press, all of the face will be temporarily hidden. To show the temporarily hidden faces, press Shift Alt. Show all of the temporary hidden face with the transparent state. Control Shift Alt. Alright, the mate lightning bolt or multiple mate mode. Multiple mate mode enables you to select one face in order to mate multiple parts to it. In figure 14.15 show the interface for the model, which from the toggle with the mate property interface for the model becomes model icon looks of the paper clip with the lightning bolt running through it. The function works only with the standard mate types, not with any advanced mates, which are discussed later in this chapter. So now we have multiple mate model interface. You can tell the software to automatically create a special folder for all the multiple mates by selecting Create Multiple Mate folder, checkbox Mate Selection Property Manager. You can also ultimately link the values, distances, angle of the mates, links, values, and selecting link dimension checkbox. When using the link dimension checkbox, the distance and angle value of the mates made and the multiple mate mode will be set equal to the link values. If you're a fan of pre-selection of mates techniques, sometimes use the mate macros. Multiple mate mode is induced by selecting the 3 cylindrical faces, 5 planar faces. When you select 3 planar faces, a symmetrical mate is induced with 4 planar faces. A cylindrical or conical selected along 2 planar faces with mate mode is activated. Taking advantage of smart mates. Smart mates are make that can create automatically dragging one onto the other without invoking a mate command. There are different methods you can use in applying smart mates. Alt plus dragging the part with the one window to the other with using the mate reference. Alt dragging smart mate. Probably the easiest way to create a smart mate quickly with the alt dragging with the 1 and 2, even and 3 mates can be applied at once, holding down the alt key while dragging a face of the edge from one part of the end to the face of the edge with another. When dragging a part with pressing the alt key, the part is made transparent so they are unable to use the other parts of the face, which when you want to make special cursor appear with a smart mate is to be applied. Figure 14 shows some of the cursors that appear with adding concentric and coincident mates. When you drop the face of the edge of the mating and the face of the edge completely with the mate, you must use the pop-up mate in the toolbar of the accept the alt or the mate. Example, figure 14:16, face is being dragged onto another. However, the obstacle on the edge of the vertices make limited being the coincident and concentric. Alright, applying smart mate. Now you've smart mated these together. Pegging a hole made with a combination concentric of the coincident mate. This is the type of the mate that created between the screw hole with the result of the alt dragging of the circular edge of the circular onto a circle edge. Circle edge created with an intersection of the cylindrical fat face with the face and flat face. Concentric mates go between the two cylindrical faces with the coincident mates go between two flat surfaces faces. Pegging a hole mate is illustrated in figure 14:7. The image show the state of the parts before with the smart mate. The image in lower left show the smart orientating part with the wrong way, so the two parts interfere with the image of lower right. The part of the smart mate is applied has been reorientated with the tab being pressed with the smart mate except for the being dropped. If smart mate tries to put the parts together in the wrong way, you can press the tab key to flip the alignment. You can see with the process of alt dragging, make sure that the release the alt key before pressing the tab. Alt tab combination window shortcut shows the list of the other open applications. Alright, figure 14:17, use smart mate, create peg in a hole, mating. Alt drag the edge. Alt drag smart mode makes original coordinate system. When you alt drag an original with the special cursor to the left, when you release the mouse button pop-up option shown in figure 14.8 appears. If you only want the origin points made coincident, turn off the align axis option. Align axis the option origin points coincident X, Y, and Z will be parallel to the same direction counterpart origin. 14.8 shows the aligning axis the option pop-up option black origin mates. Dragging between windows, you can simply control drag face with a part of the face and another part of the different Solidworks window. Probably useful with the windows before creating kind of a smart mate. Be aware, tab functionality changes with the remates applied with a simultaneously the flange mate being created. Using mate reference of the mate reference model's face edge of the vertex of 3 selected. Use the smart mate like function you use when you drag apart with the window explorer from the library window. Mate references are discussed in Chapter 18 using library assembly feature for the whole wizard of the curse for the discussed library parts. They're a greater way to automate with the common mates with the commonly used parts such as the library parts. Using a component window, show the part with a blue window over it in the back. Component preview window splits the display, opens with the right with the remain with the graphic window, allows you to inspect, rotate, zoom, and select with the perform other tasks. Open the window, click the open component in the assembly view of the preview component tool. Context menu with the drop down menu with the tool component preview window. This display with the component with the main graphic window that turns the transparent. You select from the main window with the preview window for the mate selection. For example, when the preview window is open, the smart tool bar is displayed in the exit preview button is shown in figure 14.9. The component preview window is shown on the right. Alright, and then it shows two parts with a mating symbol to it. Using copy with the mates enables you to copy the component once instant that is mated into place. The multiple instances that also mated into place. This is not different. This more shortcut inserting mating in one place. Component multiple times. This time it saves you reincarnating all mates, making copies of the component, remembering the component, and it can be a single part with a sub-assembly. Copy with the mates icon can be found in the right menu button, right mouse button. Menu on the main assembly toolbar, although it may not be there for by default. To copy the mates for the tools, you must start with the component mated in place. The workflow of the copy mates is also as follows. Start the component you want to copy made with another part. Right mouse button, component copy. Select the copy with the mates and copy with the mates property manager. Make sure the component is to be copied and selected. And click the right arrow to move to this next step. Note the second page of the property manager contains mates associated with the selected part to be copied, shown in figure 1410. In the face will select the multiple mates, collect the repeat box, select face of the example, single face, several of the bolts heads with the mate, select other faces of the mate, copied parts, clicking the green check mark for each of the selection to be placed on the copied part. For practice, copy with the mate solid assembly from the download material for this chapter, 1410. Using copying mates with bolts and holes, we've done to the property manager copy mates. We've pinned it. We've components that have been placed. Press OK to the component. And we can concentricity of the mates, and we picked face, repeat in one direction, coincident, repeat, and face are checked. Mating with the macros. If you're just applying simple mates, you do not prefer to have to deal with all of the confirmation from mouse click with the open and closed windows. You may want to use the macros mate parts. Macros won't give you the same flexibility, but simple predictable mates will be greatly increase your speed. You must have the parts ready to go when you press the macro button. You will create a wrong mate, or you will create the wrong mate. You find macros, concentric, parallel, perpendicular, and tangent mates in download material. For example, the concentric macro, you need to pre-position the parts so that they are 90 degrees of proper alignment and have one of the parts mated in place, so that only one part will move. Select the two cylindrical faces, then run the macro. Ideally, the macro should be connected with the hotkey so the workflow for this process will work extraordinarily fast. You can click one face, click the other face, press the hotkey, and then the parts will fly together. Note to connect the macro to the hotkey. First, put the macro in the folder, identify the tools, option, file location, macros, then restart Solidworks. Then use the keyboard dialog box tools, customize keyboard, assign hotkeys to the macro and list. Like smart mate macros work best with simpler mate types when you do not need to select any options. Workflow in the macros can be very fast, but you must have the parts pre-positioned very sure that you want to and what you will get. Alright, mating for motion. Dynamic assembly motion is a powerful tool for visualizing motion of the mechanism in SolidWorks. It works best if you have a single 1 degree freedom. Assembly with a more open with a degree of freedom can be do unexpected things when you're trying to move them. If there are multiple possible positions, the parts could jump between those positions. If the assembly has parts with unrelated open degree of freedom, such as fasteners not constrained rotationally with an articulating arm, you may have the same difficulty getting the motion you want. Keep in mind that it's not assembly. Not all assemblies can function multiple roles. For example, if you're trying to single assembly with accurate middle of materials exploded via dynamic assembly motion, setting up a context reference and rendering it, you may find it even if you're using the configuration covered in Chapter 8, selecting secondary features to divide the types they still might interfere one with another. For this reason, you may want to consider separate assemblies for the type of data they're most likely to interfere with the other purposes, such as anything to do with the moving parts around the dynamic assembly motion, as in animation rendering or others. And the question you need to ask yourself is whether the dynamic assembly motion is actually necessary. Often people just set it up because they can. They have unnecessary difficulties. For example, the parts with context references should have no motion, but between the parts involved, the reference part moves. Hole and boss reference parts may also move, and the sort of thing can be managed. Required discipline. There is an element of risk to the integrity of the data. Untrained and forgetful users gain access to it. Analyzing degree of freedom. When working with motion in SolidWorks, you need to be comfortable with the concept of the degrees of freedom. We inserted into assembly each component after the first one inserted, with which fixed into place, begins with 6 degrees of freedom. Translation X, translation X, which is TX. Translation Y, translation Z, rotation X, rotation Y, rotation Z. When applying mates, especially with the troubleshooting motion over definition problems, you must look at how the mates translate into the edge of freedoms being tried down. For example, the coincident mates planar face. If the planar faces ties down with the translation degree of the freedom in the direction perpendicular to the faces, 2 rotational degrees of freedom about the direction which line with the planar faces, which remains true. Translate the degrees of freedom planar faces, 1 rotational degree of freedom about the axis perpendicular to planar faces. A point-to-point coincident mate ties 3 translation degrees of freedom, and the part can only rotate. At an edge, coincident mate ties down two transitional, two rotational degree of freedom. As a result, the part mate is in this way that it can only one slide along the mated edge of the rotate and the mated edge tip. When using face-to-face coincident mates, it takes 3 mates to define a block type of the part fully. When using edge-to-edge coincident mates, it takes only 2 mates. Something to be careful about with the degree of freedom analysis frequently predict over-defined mate scenario. Solidworks does not, in fact, display any errors and warnings. Example: if one block is mated, another simplified with 3 face-to-face coincident mates, and each coincident mate ties down transitional 2 rotational degree of freedom. Mating scenario ties down 9 degrees of freedom, so the part over-constrained with 3 rotational degrees of freedom. However, the Solidworks have a lot of forgiveness built and commonly allow situations like this, which parts are subtly over-constrained. Troubleshooting over in a constrained situation, you should not take forgiveness for the granted. Solidworks report and assembly over-constrained with a reason for not intuitively, obviously, reducing some of the degrees of freedom constrained. For example, instead of making 2 coincident faces coincident, consider making simple parallel, making it mating or point to face instead of 2 faces. Best practices. This may be an overly cautious approach, but it can make the difference between assembly that works and one that errs frustrating persistent. If you're careful to approach all parts with the degree of freedom analysis in mind, then the newly added mate does not duplicate any of the other degrees of freedom that are already tied down. You will have fewer assembly mates errors and fewer problems with the assembly motion. This means instead of having the traditional 3 face-to-face coincident mates, you would have 1 face-to-face coincident mate. When locked down, the transitional degree of freedom, the 2 rotational degrees of freedom, and 1 edge of face-to-face coincidental degree locks 1 translation degree of the freedom and 1 rotational degree of freedom. 1 point-to-face coincident mate with locks down the transitional edge of the degree of the freedom. The count of lockdown all the 3 transitional, 3 rotational degree of freedom without over-defining them. Any of them is true with the Solidworks internally. Compensates over defining degrees of freedom, but relying on it to do so by an tempting fate with methodically over defining all assemblies is the risk that you do not have to take, even though it's a common practice. Or setting up successful motion. Best bet with creating motion Solidworks assembly to leave open single degree of freedom. This means that there's one way of the part and back and forth by translation or rotation. Computers in general that does not respond well to ambiguity, dragging an item that might move its other ways most likely to cause jerking and hesitation motion. A good example of the kind of problem of the motion could be found in one of the sample assemblies, and some of the Solidworks example include the downloaded material for your conveniency, and shown in figure 1411. The file name of the assembly is plunger solid assembly. Figure 1411 shows the assembly of the best motion part. You have the drag here for the motion will be shown, and the drag here for the motion will be rough or uneven. If you drag assembly parts of the location shown in figure 1411, the performance variable because of the drag handle part of every position of the handle. There's only one solution of the rest of the parts. However, when you drag the plunger for every position of the plunger bar, there's 2 possible positions of both lengths of the handle. One possibility is shown, and the other would be a handle interfering with the base of the assembly. The kind of ambiguity cause of the problems Solidworks assemblies, such as assemblies that have open degrees of freedom but will not move only in a jerky fashion. Another example of difficulties related to open degrees of freedom motion is shown in figure 14.2. The gripper's end of the move. Gripper's end of the arm moves, the rest of the arm moves, but the grippers cannot independently control by dragging. This fixes the problem. You want to fix float option available through the right mouse button menu. Use the configuration of the mate, suppress the unsuppressed, fix the parts. You want to remain stationary closest to the part that you want to remove. Remember the float part when you finish. Also be aware of fixing the part. May over define some of the mates, and you can open this assembly with the download materials in the file name called Robot Assembly Solid Assembly. Right, again, we see 1412 of the robot and starting with a degree of conflict, degree of freedom of conflicts. Sometimes dragging parts more slowly can help you get resolved by expecting more easily, although moving the parts more controlled manner, for example, the use the move with the triad, move it along the X, Y, and Z, helps software resolve ambiguity. Alright, then he has the little arrow with like a little something with that. Reference entities are particularly useful angle mates. I believe this is an angle mate. The reference entity planes are faced perpendicularly clear with both the angled entities. You can think of this as like a section plane that defines the angle. Solidworks never really mentions it when you place it and measure the angle between two faces. It takes the minimum angle, but depending on how you measure the angle, there are infinite options. This sometimes leads to confusion, user ambiguity with the software, and so this would be going to be the angle entity. Easiest way to use function: click on the autofill reference entity in the left box button with the property manager shown in figure 1413. We'll select something appropriate for you. 1413 shows angle mating, mates, faces, auto mate, then the angle mated, which is shown over here. Dimension selector disk under the cursor of figure 1413 disk is broken into blue and yellow quadrants. Angle pivoted axis. So this shows your angle pivoting and that was your angle option, angle mate. Alright, working with advanced mechanical mate types. Advanced mechanical types greatly expand the number of ways you can part together. Assembly kind of the motion you create with advanced mates take symmetry with a path mate, linear coupler. Limited mechanical mate types include cam, hinge, gear, rack and pinion screw, universal joint. You can access advanced and mechanical mates by expanding the corresponding panel of the mate manager, by expanding the corresponding panels of the mate property manager for figure 14.1. If you understand the sketch relation, standard mate relations fall into place easily. One exemption with the lock. Mate lock is different from fix, which pins a part to the background. The lock mate locks two parts to one another, so they always maintain the same relation to one another, regardless of how they move with respect to each other. This section goes into some detail with advanced mechanical mates, a brief example of each. Alright, the screw and the rectangular profile center mate. Profile center mate aligns center area with the two selected faces, slashes regular polygon circular shapes. For example, the rectangular face circular sketch will mate, but you substitute the rectangular or a plus or a T-shape, you will get a warning message. Selected entity is not invalid for current mate type. If it also accepts the inner holes in the faces chamfers, fill it to the demonstrating figure 1414. You get this option offset selected faces for location, rotation, select orientation. The mate type is still new. You can be forgiven for hoping the SolidWorks might be in the future include other profile shapes in addition with the rectangular and circular. Hint: the enhancement request is HTML form SolidWorks thread 39406. Figure 1414 shows setting up a profile center mate, mate selection, advanced mates, and the profile center dimension, the fill dimension locks, symmetrical width, path mate, linear coupler, dimension, angular dimension, mate alignment, up and down, a symmetrical line through a box. Symmetric mate works like symmetry relation with the sketch, except with the plane used in plane symmetry is instead of construction line. Figure 1415 shows symmetric mate being applied with a gripper draw. Symmetric mate is listed in advanced mates plane of the mate property manager. Figure 1415, you've made a symmetric mate, and then they showed the profile center width, the path mate, linear dimension mate, the symmetry plate main. Alright, then it shows the cam mate. Cam mate creates a special instance with the coincidence tangible mate 4 condition exists. With the cam mate coincidence, the vertex of our mated with the cam created with a single closed loop face span clip, circle or ellipse tangent, cylindrical planar face made with the cam created with a single closed loop face. Cam mate coincident vertex of the flower mated with the cam created with a multiple face with the condition enables the flower to go around the cam without stopping at broken face and following with the extension of the single face cam mate tangent. Cylindrical planar face mated with the cam that can create with the multiple face with the condition and enable the flower to get all the way around the cam without stopping at the broken face following the extension of single face. Figure 1416 show the multiple face cam setup along with the cam mate interface. The example of the files available to download material chapter file with the cam solid assembly. If open with the assembly spin cam plate, You will notice that in both cases the flat follower does not work very well. In fact, single face cam assembly, if it does not work at all, the place playing interface is considered infinite place and playing for the purpose of planning. For more information, take a look at the HEM forum Solidworks.com thread 203350. No parallel cylindrical cam use the cam mate create cam motion, but they do work in the path mate. Path mates are covered in more detail later in this section. Alright, so now we've gone on to mate with a cam mate, and it shows the cam path and cam follower. Standard mates, advanced, and mechanical mates. Alright, two planar interfaces with mate is often either the replacement symmetric mate with a situation with each part of the model with a tolerance gap rather than touching the face. The with mate requires two pairs of faces to be selected as particularly well with the part may be spaced evenly. Some of the percentage of one side between the two faces is not mid-plane. For example, the square key with the place of the square keyway. This is somewhat larger than the key. The dovetail keyway are another good application for this plane. The mid-plane is available. The symmetric mate may be a better option, or at least feature faster than one to mate. Given the symmetry rates, mate requires only two faces of the plane. Figure 1417 shows the good application of the with mate as well as the property manager interface of the mate. Figures 1417 shows the center of one part orders with mate. So we've done widths, faces, tab selection, width, constraints, center free or dimension, and percentage. Alright, your gear mates enables you to establish gear type relation between without making parts physically mesh. You can apply gear ratios, direction, physical connection, so you can have shaft out, blackout transmissions without requiring the detailed gear profiles. You can open an assembly figure 1418 from the download material and file gear mate solid assembly. Select this effect, open the assembly, rotate the parts, edit the mate chain to the ratio direction selection. Gear mate is two cylindrical faces, two circular edges, sketch and pitch diameters are used. So now we selected gear, we've selected our faces on the gears. We use standard advanced mate slots, gear ratio, 2 inches to 1, reverse rack and pinion screw, universal joint. Our rack and pinion shows the gear on top of a pin. Rack and pinion makes two rotational motions in one part and turns the transitional motion for a second part. In the part does not need a physical connection. It can be simple representation, actual geometry, and the need to derive a motion in real world shown as an assembly that uses rack and pinion mate. You can find this assembly download material file named rack and pinion mate solid assembly. Alright, your limit mates, you can apply limited distance angle mates in order to allow the parts to move within a certain range of value. Figure 1420 shows the property manager interface limited angle mate. Limited mates accept 0 with a negative value that's normally accepted for the dimension. Solidworks, when used properly, limited mate can be an extremely powerful tool for creating more realistic motions in assemblies. Applying rack and pinion mate. Applying a limited proper manager. In the download material of the chapter, open assembly robot limited mate with a solid assembly. Drag the robot tower apart. Note that the rotate 1 to the limited angle. Limited angle 2 is mate that is driven for this motion. Note that the angle limited mates, the angle mates, I strongly suggest you for the new reference and need option for the defined reference a quadrant for the angle, otherwise with the danger of flipping mates. Alright, your screw mate functions just the way the name suggests that every real revolution of the part relative to another part moves the linear direction of a specified moment. The mate requires two cylindrical faces, and the pitch value is shown in figure 1421. Setting up a screw mate. Screw mates can be handy for lead screw animations, although not recommended with the gear modeling. However, the working with the animation, fantastic addition to the mate toolbox. Alright, and then we go to path mate, which is one that makes complex barrel cam motion possible, as well as the other path-driven motion. Another application mate type beyond barrel cams is further the motion camera fly through animation path. Mate requires a point of vertex on one part, curve selection on the second part, of the path selection is not just a single sketch curve at any, requires the use of selection manager, which enables you to select a multiple end-to-end either from form closed open paths. Figure 1422 shows the setup of the path mate. Barrel cam solid assembly from the download material demonstrated the selection necessary to make this work. Path mate includes some controls keeping the follower properly orientated. One of these roll and control, which enables you to specify the upper vector. Then second of these is the pitch and yaw control, which can be free and controlled within the path. So this is setting up a path mate. On the barrel, figure 1422, note that the sketch point is being driven along with the path with a reality that does not exactly reflect the motion of the follower around the cam. So the path mate does not take into the action tangent contact between the surfaces. The assembly driven the point around the curve that slightly amount with the air of the scenario, such for the leading of the trailing surface of the follower with the interfere with the cam angled slope, depending on the angle of the cam surfaces. Also note the path sketch and even if it has nothing to do with the path mate, it is not required to make the path mate work. You may find that works better with the control motion using animation motors than the simply dynamic assembly motion driven by the mouse. Alright, your linear coupler shows two different directions. Linear coupler mate relates motion from one part of the direction to another part in either the same or different direction, enables you to apply the ratio between the motions. The direction does not have to be perpendicular, anti-parallel. They can be right angles at any angle with the mate control of the motion only in one direction. Some of these directions are free to move. Use the mate simulate the symmetric motion with the geared motion without modeling the rest of the detailed mechanisms. Figure 1423 shows the setup of this mate. Show the mate selections. Standard mate, advanced, profile, symmetrical, synthrial, linear coupler, ratio, reverse. Alright, your hinge mate. Hinge mate is just a shortcut of making concentric mate, coincident mate, combined, angle and limit mate, but does its similar feature with a single interface. Figure 1424 shows the property manager interface hinge mate. Belt and chain assembly features not technically standalone mate, but it uses the mates to accomplish this. You can use the belt and chain features two ways to create relations between sketch blocks and create relations between parts. Feature also creates a sketch and solid part representation. Belt and chain initiate belt and chain function from a toolbar bottom assembly toolbar through the menu, choosing insert and assembly feature belt change. Setting up a hinge mate, he says show the concentric, coincident, angle settings, degree, dimension, inner dimension, standard, advanced, mechanical mates, hinge. Editing and troubleshooting. You should become proficient with editing and troubleshooting assembly mates because you're able to spend a fair amount of time with editing assemblies. After you master the technique, you'll be more confident that willing to experiment with the assembly chain of the assembly with the air with the more slowly unpredictable. Others who use the assembly makeup used about the assembly design intent leave error to the model. Always good practice to leave your assembly error from the next user. Editing existing mates. If you're editing just one mate, you can simply right click it and select edit feature. If you're using context toolbar, left click it, right and click edit tool feature menu bar. Remember that you can find mates in places other than mate folders in the bottom of the assembly feature manager, and most notably you can find the folders under the parts of the mating together, or you can also select View Mates on the right mouse button, left mouse button menu part with the assembly for multiple selections of parts to bring up a small window containing all the mates that involve the selected parts. Mates are listed in breadcrumbs. You can bring the breadcrumbs of the cursor with a D hotkey of the breadcrumbs can very handy with quickly find items related with whatever you selected at the time. You can make several types of changes of the mates, including changing selection mate types of mating alignment. The types of change all shown in figure 1425. Displaying mate being editable. Select faces are highlighted with the graphics window. To edit multiple mates consecutively without exiting the mate property manager, you should pre-select the mates. Pre-selected mates are shown in mates panel figure 421. You can switch from editing one to another, simply selecting new mate with the mates panel, selecting one mate before clicking edit feature. Realizes later that you want to edit multiple mates. You can select more mates through the feature manager. When mate entities are lost, a mate appears grayed out. You can repair the misring reference problem, selecting the invalid reference of the mate selection window. Selecting correctly the item with the graphic window. Multiple mates are missing the state Same reference repair within one of them. Solidworks gives you the option to replay with the new reference in with the rest of the broken mate. The yellow triangle symbol in front of the mate that is satisfied but is conflicting with another mate that is not satisfied. Repair mate shown in figure 425. 1425 with the missing fate for the entry with the property manager. Select with the correct fate for the graphics window using any of the selection options available to Solidworks. Missing reference you for the multiple mates is a repair option to repair all the mates in you. But it's important to know that you attempt to apply with the would-be contradict existing mates. The three option cancel application, new member mate, break the new mate, and break the other mates, troubleshooting assembly mates. Best troubleshoot with assembly mate problem as soon as it appears, not after it becomes complicated by other usually ailed mates if it can cause the problems of the Solidworks. Keep the track trying to solve the mates of the conflict with others. Assembly problems often appear with a tree far larger than they actually are. For example, the entry of the entire tree with the mate light up with warnings and error message with one extra mate with is applied. You with the conservative approach with the troubleshooting situation, like for example, you can purposely over-define mates just like the leftover mate with a mate that is not supposed to be there. Two types of symbols with the mate help with the distinguish kind of the error with the present and the different mate feature. The yellow triangle to contain with the exclamation point is an error. It's actually more of a warning. It tells you that the mate is in conflict with other mates. The symbol gives the variety of warnings, but the mate is satisfied geometrically. One of the other mates which has conflicts probably is not valid. The type of the warning is usually accompanied with an actual error symbol which the mate is not satisfied. A red circle containing an X and failed mate. The mate is conflicted as invalid and also coincident mate. The two coincident entities are not coincident. To make it easy to find the problem mate, you click over the top level of the assembly name and the assembly manager to display all the option mates under warning, errors, and messages shown in figure 426. 1426. So 1426 shows the mate errors and warning top level. Troubleshooting, warning, and error. Solidworks distinguish between errors and warnings. Error of the situation condition when not satisfied coincident mates. The selected entity not coincident with the errors are marked with the red symbol. This warning make mark situations like to exist. Otherwise, if all conditions are met, yellow triangle, the explanation point. For example, both the coincident and perpendicular mates are used the same fate. One mate will have the error with the other warning because the other satisfied, but not both. You can use the following troubleshooting techniques to work with the assembly where errors and warning exists. Last is first out. What mate is added with the curse of the warning error sins that appear throughout the design tree can usually correct with the problem. Remove the last mate. Single elimination. If you're sure that the last mate added is corrected, but you may want to go backward or upward of the tree, starting with the bottom, suppressing individual mates until you find the one that comes with the warning error sign with the disappears from the tree. Single addition and is either to take the opposite approach with suppressing all but the mates that make sure of that you are sure of, and then gradually on suppressing mates until the conflict appears. Suppress the part when all the mates are active to try and suppress the individual parts, see whether they make the difference. If it does, the unsuppressed part will look at the mates of the part with the mates folder under the part. Mate expert with the main expert automated routine creates subsets for the groups of the conflicting mates. The subset of the mates of the one mate that's satisfied because of the conflict. This may help define the cause of the conflict. Figure 1427 shows the mate expert interface to resolve the mate expert. Right mouse button on the menu on the mates with the errors with their main menu. The tools evaluate. Examining mate options, option paint with the mate property manager shown figure 1428 options, control actions taken and newly created, add a new folder, puts the newly created mate into its own new folder, turned off the new mates to put on the top level after the last folder. Show pop-up dialog shows pop-up list of the figure 14.2 when a mate is being created with the pop-up list display with the graphic area of the new geometry selection from the mate. Show preview pre-position mated parts for the existing command using position only position if the part does not apply with the remember the mate sum. Usually select the option various options application where they need the part located with the previous slightly, but they do not need with the want to meet the feature of in one. For example, using this option position of the part animations where the part does not move according to the mate. Make first selection transparent with a mention earlier within this chapter. Turn to the first part, but you select the mate transparent to the user and to the cursor. You select whatever is behind it. Options pane, mate manager. Reviewing mate best practice. Sometimes the best practice recommendation can contradict one another. For the best practice of the recommendation found in the likely specific situation where the recommendation is invalid or even a bad idea. As a result, you should apply the following recommendations. Carefully, do not take practice too seriously, but you should not disregard they all go together. Some companies use best practice recommendations of the following. Standard with less experience with their Solidworks teams more need standards of these sort. Every situation has a different need for the practice, but even the need set of the rule of the different from the ones laid out. You can think of the set of the mate with the best practice starting point with a discussion at your own company. Each pod assembly should have at least one part of the either fixed or fully mated with a chain plane with assembly that cannot move the relative assembly. Use fixed parts sparingly. One part served with the ground with the other. Assembly should be fixed with the other that more parts are imported assembly, sometimes fixed to keep from being moved accidentally. Do not mate the time dependent feature with the assembly tree part and components with the intended context feature of the part that can create the circular reference for the assembly must be rebuilt multiple times to fully resolve the position of all the parts and sketches. When possible, mate all the parts of the ground part, creating a daisy chain mates where the mate A mates B and which mates C and so on. Force mates to be solved with a particular order with which may take the file more time to solve if the mates may relate with established assembly reference to mates that may be more stable. Chapter 13, move the efficient assembly with describing the skeleton with the part with the mate and make sketch and the feature relations apply with a similar concept of the assembly mating the part with the assembly sketch. Where possible, leave part of the position fully defined, especially with the other geometry dependent upon the position of the parts. Example, include with the context feature, assembly features assembly level reference geometry, which are dependent on the part geometry constraint, rotational degree, freedom of the components, screws, washers, nuts, usually conserve the excess of the time. Too many open a degree of the freedom may cause problems with complex motion, such as the gripper end of the robotic arm. Solid work functions when and where. Well, when the singly well-defined path between 2 points, but when the multiple option software may be confused, do not leave errors unresolved in the tree. Remember to subassembly break up the number of the mates that are solved in the top-level assembly. Limited the flexibility of subassembly. Do not make any that may be removed by suppressing unsuppressing features, especially the edge of fate of the created suppress feature of the touch to fill it. For this reason, usually best way to wait until all the parts complete before you creating an assembly through the rarely practical. The degree of the freedom in light of the prevent the mates from becoming overdefined. Made the hardware nut bolts and the main components, not the other way around. If the hardware is suppressed, assembly motion should be should be unaffected. That last one was mating the hardware's nuts and bolts, main components, not the other way around. Hardware is suppressed, the assembly motion should be unaffected. Tutorial mating for success. The tutorial will put together the model with the robotic arm, better understand some of the main issue discussed and shaft the file step to make the success. Open the part name robot base solid part with the dollar and website of the part with the document. Click over the make assembly from the part icon. Click over the cursor for the origin assembly to place the plate as origin assembly origin place for the automatically fix in the place. Alright, and that's the file out assembly, choose insert component existing part assembly, click the browse button with the property manager, find the part called robot tower solid part. This part contains mate references to help you maintain the mount, the base, the bring, and the cursor near the big circular hole in the base. You can preview with the top of the tower, snap it into place. Click to accept the placement. Figure 1429 show the placement in progress. Note if the rotate context toolbar option, the bar itself of the graphic window helps you to get with the newly placed part orientated correctly. Also note the cursor appears. Smart mate cursor peg and hole mate with the part is dropped, and check the mate list and confirm the concentric mate with the coincident mate that have been applied with the mate reference. Alright, so 1429 we use a smart point component. Open the arm of the file name of the robot arm solid part of the default configuration. Open the window, choose the window type of the tile vertically. The part with the assembly should be open adjacent windows. Click the face inside of the hole with the chamfer around it. The arm part shown in figure 1430 with the dragon assembly with the cylindrical face inside of the hole with the top of the robot tower part with the concentric smart mate symbol should appear on the cursor. Alright, 1430, displaying the displacement of dragging between the windows, dragging the interface over the hole, and then click the green check marker, shift the concentric mate, move the part test of the mates for the correct with the mate tool, the assembly toolbar, expand with the advanced mate with the click on the width main, and width selection, select the two interface with the robot tower part. Within the tab selection box, select the other face with the upper arm part of the selection should look at the shown figure 1431. Open Windows Explorer window, select the following parts: robot arm 2, robot gripper with the dragging the these part of the SolidWorks assembly window to drop them in the blank space. So for the chambered arm face for the arm and arm part 2, create with the coincident mate with the between them and coincident mates between the clinical faces along with the cones of the same angle. Special cases of like combination of the concentric coincident mates at figure 1432 shows selection in the results. 1413.1 shows creating a width mate. Alright, making clinical faces coincident. Select these faces. Create a copy of the gripper for the 2 instant with the assembly. You can create control drag with the assembly window with the mate property manager. When both grippers and arm 2 use the same mating technique they used for the previous clinical incident part. After you have applied with these products, try the move of the various joints in the assembly. Notice that it is difficult, it is not impossible to isolate the motion in just a single part. This is because there are too many open degrees of freedom and loss for the ambiguity. Fix arm 2 with allow with the move of the gripper parts you want. Create symmetric mate between the indicate the face of the grip of the front plane and arm 2 as part shown in figure 1433. Creating a symmetric mate, and then show the faces symmetric mate. Practice making angle mates, suppressing mates, fixing part little motion, save the assembly, editing, exit the file. The bottom line, although through understanding mates, their editing, troubleshooting techniques, particularly make the difference between the real assembly artists and the either the struggles through they avoid in certain tasks. Much of the about mates not straightforward, but with this practice, you can understand, master them. You can put assemblies together with a quick focus on rebuild, performance, dynamic assembly, motion. All the best practice concepts should not dominate your design. Great guidelines from which you start to avoid making big mistakes. Watch out for the pitfalls outlined on page 27 in reviewing mate best practices section of the chapter of the summarizes the mate's best practice files. Master it. Smart mates are key to putting assemblies together quickly in SolidWorks. Practice for the smart mates are single assembly windows. Also between the part and assembly titled with the tiled windows. Practice for the U of the tab, clip of the flip of the orientation of the mate. Master it. Make sure that you understand the function of mates. Go through sample assembly. Sort through the mates. Prevent motion. Make it enable the motion. Put these mates into separate folders. Master it. Works through several specialized mechanism mates. Make sure you can sample and assembly to recreate the motion. Use the part sample assemblies for each of the mates reassembled parts so that you have the intended the motion. Chapter 15, Patterning and Mirroring Components.